Hello guys, this is an Pichon. Welcome to my mathematics class. Today I have taken this topic. Topic is a method to find inverse of given matrix. If we have a given matrix, then how to find out the inverse? In one video I told by definition how to find out the inverse. Today I will tell you here how to derive the formula for inverse of square matrix. Let's see, here we go. Let A is equal to A, B, C, D be a given matrix. Given matrix. Then you will find out, okay, given matrix, then determinant of A is equal to determinant of A, B, C, D. Let's by definition it will come AD minus BC. Let's suppose not equal to 0, suppose, right? If determinant of A is not equal to 0, therefore we can say A inverse exists. So if A inverse exists, let's suppose, okay, let A inverse is equal to your any other, you can suppose P, Q, R, S. P, Q, R, S. Okay, these are the elements of A inverse we have supposed, right? By definition, we can say we have A into A inverse is equal to I. I means unit matrix. By definition, they are inverse to each other. Then product is equal to identity matrix. A is equal to your A, B, C, D. A inverse we have supposed P, Q, R, S is equal to I means 1, 0, 0, 1. Identity matrix of order 2. You just multiply AP plus BR, then AQ, this into this corresponding elements, and this will take AQ plus BS. Now S turn this into this means this into this plus this into this, CP plus DR, and here CQ plus DS is equal to 1, 0, 0, 1. Now two matrices are equal to each other, then corresponding elements also equal. Okay, then their corresponding elements are also equal. If corresponding elements are equal, we are equating the corresponding elements, we get AP plus BR is equal to 1. Let's suppose this is the first equation, and then you can write down CP plus DR is equal to 0. Either you may write on this one, this is the second equation, and here AQ plus BS is equal to 0, third equation, and last equation CQ plus DS is equal to 1. Okay, this equal to 1, this equal to 0, and this equal to 0, and this equal to 1. This is equation number 4. Now we will solve. We have to find out the value of PQRS, because we want to find out the elements of A inverse, right? Because these we have supposed element, these are not the actual elements of A inverse. Okay, we have to find out in terms of ABCD. So let's solve. Solving 1 and 2, we get, here I will write down directly, but I will tell you how to find out. Okay, here see AP plus BR is equal to 1, or CP plus DR is equal to 0, right? So from these two we can find out, okay, firstly either P or a R we can find out, right? Let's make, okay, I'm going to make the coefficients of P and P equal, right? Let's, how to, just multiply this by C and just multiply this equation by C and this equation by A. Whole things you have to multiply and whole things by A. And after this you will get, okay, ACP plus BCR is equal to C, and here ACP plus ADR is equal to 0, and then subtract and cancels. Here you will get minus here BC minus AD is equal to, yeah, bit 0. Okay, no need to use any sign because 0 is neither positive or a negative, so that's why you can leave here. And comma R common is equal to C, or you will get, okay, R is equal to, here I'm writing. So I think you understood how to write down, okay, these things. Okay. Here you will get, okay, R is equal to C upon BC minus AD. If you change your sign, you will get here minus C upon AD minus BC. If you multiply up and down by negative sign, then you will get minus C upon AD minus BC. We want to get, okay, AD minus BC. If here is AD minus BC, we can write down determinant of A, right? Okay, that's why I will change. That's why I have written in terms of AD minus BC. This is the value of R, AD minus BC. Now putting, okay, putting R is equal to minus C upon AD minus BC in any, okay, in first, okay, then you will get, okay, what you will get if you, okay, substitute value of this one into for either first or second, in any, okay, you can use, okay, right? So let's use, okay, second, because there is 0, it will be easy for calculation. CP plus D into minus C AD minus BC is equal to 0, or we will get CP is equal to DC. I've transmitted on right hand side AD minus BC, or you will get here P is equal to D upon AD minus BC. So okay, here now I'm writing, okay, directly. I told you, I, okay, explain how to get the values of P and here R, right? So P is equal to, P is equal to D upon AD minus BC, and R is equal to, you will get minus C upon AD minus BC. Okay, and similarly, yeah, again solving 3 and 4. So solving again better, okay, I'm using again because here I've written directly. Solving 3 and 4, you will get, okay, here we got, okay, P and R. From here we'll get Q and S, okay. Q is equal to, alright, you can solve because you don't know, but I know, right? Okay, so that's why I'm writing, okay. You will get Q is equal to minus B upon AD minus BC, and R, you finally S, you will get is equal to A upon AD minus BC. Okay, these are the values. Now we have to substitute in A inverse, right? So therefore we can write these values. Therefore, okay, A inverse is equal to, you will get here P, value of a P, here D upon AD minus BC, and PQ, let's write down here Q, minus B upon AD minus BC, PQR. R here is minus C upon AD minus BC, PQRS. S here is A upon AD minus BC. Now again, I'm writing, okay, 1 upon AD minus BC, this is A, into D, and here 1 upon AD minus BC into B. So here also 1 upon AD minus BC into minus C. 1 upon AD minus BC into, or here you can write down simply A into A. Now you can see each and every term of A inverse. Here 1 upon AD minus BC, 1 upon AD minus BC, here also 1 upon AD minus BC, here also you have 1 upon AD minus BC. So this means B can take this term as a common term is equal to 1 upon AD minus BC is equal to, we can write down D minus B minus C A. Sorry, here A, here A. Okay, this is a inverse. Okay? Either you can memorize in this form, uh, right? Or A inverse, how to find out, right? Or again, or let me write down, okay? This is a particular thing, okay? Already we have got, okay, AD minus BC, this is a determinant of A, and this is your adjoint of A. This is called, okay, adjoint A, where determinant of A is equal to 1 upon AD minus BC, and adjoint A is equal to, this matrix is called adjoint A, minus B minus C A. Alright, now I think you understood, or you may keep in this box, okay, this is called, okay, CTM means committed to memory. You need to memorize also, right? Adjoint A. So this is your A. Sorry, here not 1 upon whole is not, okay, only simply AD minus BC. Determinant of A is equal to AD minus BC. So AD minus BC is your determinant of A, and this matrix is called your adjoint of A. Now, adjoint of A, let me explain. What is the adjoint of A? I will tell you in simple way. Adjoint of A. Adjoint of A means, okay, transpose of matrix of cofactors of A, right? Adjoint of A means transpose of matrix of cofactors of A. Alright, transpose of matrix of cofactors, right, of A. Transpose means interchanging rows and columns of a matrix, and cofactors. What do you mean by the cofactors? Let me explain. So if we see the formula, cofactors means, okay, this one. Cofactor we write down, okay, in this formula, Aij is equal minus 1I plus j Mij. This is called, this is the formula of cofactor. This is a cofactor, cofactor of ijth element of matrix. Element of ijth element, cofactor of ijth element of a matrix, right? Aij means, okay, Mij means minor, same, okay, this is called minor, right? So I'll explain, okay, what is your minor, right? Aij cofactors, I have explained. Cofactors formula is this one, minus 1 raised to power I plus j Mij. So what is your I plus j? I plus j means I is, okay, I represents row number, for J represents your column, right? Just if I write over here any, okay, 2, 3, 4, 5, this tells, okay, position of element, okay, is represented by, okay, Aij. I means, okay, row, J means column. So here 2 means, okay, A11 is equal to 2. This means, okay, the element in first row, first column means 2. Here is, okay, A11, this is your A12, this is your A21, this is your A22. Because, okay, so, the element in first row, second column, so 1, 2. Here 2, 1, because element in second row and first column. This is 5 is the element in second row, first column, so 2, 2. Sorry, second column, right? Second element in second column, right? Position A11, A12, A21, A22. These are the Ij, right? Ij means position, row and column. I means row, and J means column. Okay. So I think clear. Now let me Aij cofactor, transpose of matrix. So cofactors. So here let A is equal to A, B, C, D. Now A11, let's find out cofactor. A11 means cofactor of A means first element, means minus 1 raised to power 1 plus 1 I plus j. So here let me refind, okay, Aij means Aij is equal to minus 1 raised to power 1 I plus j Mij. This is a formula. Aij means A11 means cofactor of first element. 1 into minor. To find out the minor of A, you have to delete its row and column. 1 means first row, first column you have to delete. You will get only D. So here D. A12 means cofactor of A12 means this one B. A12 means this. Let's apply this formula. Minus 1 raised to power I plus j. I plus j means 1 plus 2. I plus j 1 plus 2 into minor of B. Minor of B. So let's delete its row and column. B is in first row, deleted. B is in second column. Okay, so deleted. You will get only C. C is the minor of B. And here minus C. So 2 1 means cofactor of C. Cofactor C minus 1. Let's apply the formula. Raised to power 2. I means 2. J means 1. And let's delete its row and column. Its row is second row. Its column is first row, first column. So let's delete, and you will get B. B is equal to, and minus 1 raised to power 3 means negative. So negative B will get. And finally A22 is equal to cofactor of 22 means D. Your cofactor of D. Firstly minus 1 raised to power 2 plus 2, and let's find out the minor of D. Minor of D means let's delete second row, second column, because D is in second row, second column. We'll get only A, right? And so A, let's write down matrix of cofactors. Matrix of cofactors here. You will get matrix of cofactors. Let's write down cofactors D. We have calculated cofactors row wise. Firstly rows element, then second rows element, second rows element. All right. So D, and here you're gonna get minus C, here minus B, and here A. This is a matrix of cofactors. So let me repeat again. What is your adjoint? So therefore adjoint A. So according to the definition of adjoint, adjoint of A is transpose of matrix of cofactors of elements of matrix A. So transpose of cofactor matrix simply, or matrix of cofactor. This is your matrix of cofactors of elements of A. So its transpose means interchanging rows and columns. Rows and columns. Row becomes column, right? Rows become column, and this row column, and this row also becomes column. Minus B A. This is your adjoint A. Now check. So here I have written for this adjoint of A. So D minus B minus C minus C. Simple method. How to know how to find out directly. This is the long method, this is the lengthy method, and this is the actual method to find out the adjoint of A, right? But directly how to know? How to know? Simply if we see this one, if we see here actually A is your this one, is your A B C D. In order to find out the adjoint of A, you will just interchange. In order to find out the interchange the positions of elements of main diagonal. This is called your main diagonal. So let me again here. This is called main diagonal. This one is a main diagonal, or you can say a principal diagonal, or you can say also leading diagonal. So no space, so I am not writing. And this is called your secondary diagonal. So if you can see, all right, okay, secondary diagonal. This is a main diagonal, principal diagonal, or leading diagonal. This is called a secondary diagonal. So interchange, okay. In order to find out the adjoint A, just interchange the positions of elements of main diagonal, right? And here in secondary diagonal, just change the sign. Just change the sign of elements, right? Just change the sign, okay? Just change here, okay? You will interchange their positions, and here you will change only signs. So look at here. A in okay adjoint A, D is here, A is here, right? And in secondary diagonal only, okay, sign we observe, okay, there is sign change, right? Here B and B C positive positive, here in adjoint A this becomes negative, right? Okay, this become negative. Now you understood how to find out, okay, directly adjoint of A. And the lengthy method or actual method also I have explained how to find out the adjoint of A. And while finding the adjoint of A, you understood cofactors and minors also, right? In case of matrix of or square matrix of order 2. Okay. So this is the formula to find out the A inverse, right? A inverse is equal to, you can memorize like this, A inverse or inverse of matrix A is equal to 1 upon determinant of A times adjoint of A. All right. Now I will tell you how to find out the inverse of square matrix of order 2 with the help of this formula. Okay. So let's start the questions. Now I've written here questions for you. One, I will tell you how to find the inverse by using the formula. One, this question I will tell you. These questions for practice. Practice, and these are also okay for practice. Okay. Practice. These questions are given for practice, but I will tell you the hint, okay, right? By how we can find out by using the formula. Let me recap the formula. Just we have derived if we have A is equal to A, B, C, D, and determinant of A is not equal to 0, then we can find out A inverse is equal to 1 upon determinant of A into dA and minus B minus C. Here, okay, they will interchange their, okay, places, and here only sign, okay, only sign, and here places, okay. This is called, okay, this is the determinant of A, and this one is called your adjoint of A, right? Or we can write down the 1 upon determinant of A into adjoint of A. All right. So this is the, okay, method. This is the formula to find out the A inverse. Okay. So let's see how to find out. Okay. Let me bring Thurston. Okay. See. Solution. Very simple method. One number A is equal to here. A is equal to minus 1, 3, 2, minus 8. This is our question. Firstly, you will find out, okay, then you will find determinant of A. Minus 1, 3, 2, minus 8. Determinant of this one is minus 1 into minus 8, minus 2 into 3. And you will get here 8, 3 to the 6. Okay. So minus, okay, here 8 I have written, minus 1 into minus 8, 8, and 3 to the 6. You will get here 2 is not equal to 0. If determinant of A is not equal to 0, I meant to matrix is square matrix is non-singular. So we can find out, therefore A inverse exists. Right? Now let's find out, okay, inverse formula. A inverse formula is equal to 1 upon determinant times here adjoint of A. Determinant we have got. Now let's find out the adjoint. adjoint of A is equal to, what will be the adjoint of A? Here, just okay, adjoint of A formula is your, adjoint of A formula is equal to dA minus B minus C. Okay, here. So just to find out the adjoint of A, interchange their position. Here minus A. This will go here. Okay, formula. A will take the place of D, D will take the place of A. And here just change the sign, okay. Here positive, positive, and they will become negative. Positive, positive, so they will become, okay, negative. So just you will change the sign of secondary diagonal elements. And here elements of main diagonal will interchange their position. Okay, this thing. This will be your adjoint of A. Okay. Adjoint of A, therefore, okay, inverse is equal to 1 upon determinant A times adjoint of A. Okay, adjoint of A is equal to 1 upon determinant of A is 2. Here is minus 8, minus 3, minus 2, minus 1. So this is your inverse, A inverse, okay, right? Today we understood how to find out the A inverse with the help of formula. Alright, now I think you clear. Okay, so if you want to do one more steps, you can just multiply with half times minus 8, minus 4, half times minus 3 by 2, half times minus 2, minus 1, half times minus 1 means minus 1 by 2. So this way also one more step you can do also, right? Otherwise, okay, this is also correct, absolutely correct, okay, no problem. Clear everybody? No, so I think clear, right? So here one step, just multiply, okay. This also multiply by 1 by 2, 4, and this minus 3 by 2, and then this into this means minus 1, and this into this minus 1 by 2, okay. So this way we can find out the inverse. Similarly, you can find out the inverse, 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 inverse. If instead of there x, then x inverse, if y, y inverse, b inverse, right? The same method you have to use. Okay. Now here already we have discussed in earlier video. I told you how to find out the solution of this question here. If the matrices given below are inverse to each other, if any two matrices are inverse to each other, then product of the matrices is equal to I. Then product of matrices is equal to I. Okay, I think here you understood. Now I am going to erase. No. Question number hint, okay. Here is, okay, you will write on the line this way, solution, just hint I will give you. 3 first, you will write down the here. Like this way you can start here like A, and this will be this will be your, this will be here, you will write down the elements. B is equal to, okay, let me write down, okay, here is 2x, here is 7, and here you have 5, here 9, 9, okay, B is equal to, we have 9y minus 5, 4, okay, you can write down the since A and B are inverse of, inverse to each other, and B are inverse to each other. So already we have discussed, okay, according to the definition, we can write down the A, B is equal to I, where I is a unit matrix, identity matrix, unit matrix or a identity matrix. Here you may write down, okay, 2x, 7, 5, 9, and here you may write down 9, y minus 5, 4 is equal to 1, 0, 0, 1. So, okay, now I think you can do, just multiply, okay, on the left hand side multiply, right hand side, okay, same, okay. Later you can equalize to find out the value of x and y. Easily you can find out, I think, okay, after this line, alright, after this equation you can see then after this okay, situation, alright. Similarly, you can do these questions. If you get over these type of questions, you can handle like this way. If we have two matrices are inverse to each other, then you can say product of, okay, AB. If they are A and B, product of AB simply okay, AB is equal to BA is equal to I. If already okay they are inverse to each other, in order to find out the value of x, y, any other variables, okay, then you can take okay any either okay condition like okay AB is equal to I or a BA is equal to I. Okay, it doesn't matter. Okay, in both cases you will get the same values of x and y. I mean to okay variables, right? Here. So once again. Let me recap. Okay, A inverse. Today we came to know how to find out the A inverse. A inverse formula I have derived. Okay, today. And A inverse is equal once again. Okay, let me write down. Okay, here A is equal to A B C D. Then A inverse is equal to 1 upon determinant of A into adjoint of A. So but provided okay determinant of A is not equal to 0, right? And determinant of A means AD minus BC, and here adjoint means DA. To find out the adjoint, okay, you will just interchange the elements of main diagonal and change the sign of secondary diagonal. Main diagonal, secondary diagonal. Okay, you will change the sign of elements of secondary diagonal. C and minus B. Okay, so this is your inverse. Alright, this is only here interchange in order to find out the adjoint, interchange the elements of position of the elements of main diagonal and interchange just sign of sorry, interchange, not just change the sign of so elements of the secondary diagonals, right? Once again, let me tell you, main diagonal, principal diagonal, leading diagonal, this is for your secondary diagonal. Okay, so I think clear. So you just do practice by through this video and firstly look each and every step of inverse, how to find out, how to derive the formula, and see the example. One example I have solved, and then try to do the to find out the inverse of these questions. You can. I hope okay, I'm supremely confident you can find out, and these questions are very easy. That's why I have not given answers of these questions also, right? And these are also very easy. Hint I have given here, hint only, just not solve okay all questions. Already we have done in earlier video. Yes, so if A and B are inverse to each other, then you can write down AB is equal to I or B is equal to I. Any one you can take. Okay, you will get definitely answers of X and Y, right? So these two question answers I have written here, right? So please do these questions. So these are very important okay, for you, all right? So thank you for watching. If you are newcomers, let me repeat again same word, okay? Subscribe and stay with my channel. Always you will get mathematics video which are very useful for you. If that videos are not useful, definitely okay, that will be useful for others. You can share to your brothers, sisters, or your neighbors. Okay, once again thank you for watching. Bye bye.